In our last two video series, we've taken a look at numerical differentiation and we've also taken a look at numerical integration. In this series, we're going to start taking a look at methods for differential equations. And we're going to start out with being able to utilize the built-in functions in Matlab to be able to get to analytic sorts of solutions as well as the estimated solutions of differential equations. Knowing that differential equations is not a prerequisite to this course, I want to start by defining what a differential equation is. And a differential equation is exactly what it sounds like. It's any equation that contains one or more derivatives within it. And generally, there's going to be a dependent and an independent variable. So generally, we use y and t or y and x. We like to use time a lot whenever we're solving differential equations because the answer is usually going to be some sort of position function or some sort of representation of temperature at a specific time or something like that. The derivatives represent the initial rate or the rates of change, and we want to go backwards from that. Now, generally, a differential equation has a family of solutions. So for instance, if we had like the plus c at the end, we know that the plus c could be plus 5 or plus 7 from an integral, but we're not necessarily sure which one or which specific value it is. And so we have a general solution for a plus c type of problem where we have a solution, and then we have an initial value problem to where we're given some sort of starting point, and that way we can solve for the plus c, that constant. So what does a differential equation look like? Well, this is one that's not an initial value problem. So we have 2ty prime plus 4y equals 3. And the initial value comes in when we have this animal right here. The initial value is that when t is 1, y is -4. And that specifically tells us which family, or I'm sorry, which member of the family that the differential equation belongs to, or the solution does. And so what we're going to do is we're just going to be able to utilize Matlab and a few algorithms to be able to estimate the solutions to differential equations. We're not going to go through and talk about a lot of the applications, or we're not going to talk a lot about the theory behind the analytic solutions, because when you take differential equations, you'll learn those things. Now, in Matlab, the easiest way to be able to start solving differential equations is by using this dsolve function. Dsolve is exactly what it sounds like. Your differential equation solve. And essentially what you can do is you can define the differential equation and then you desolve it, and you also define the conditions of an initial value problem. So you can solve it with and without the initial value if you want to, and I'll show you that in a few moments. So I showed you the code, or right here is the code to be able to solve a first order differential. And so if we have y prime is equal to sine t minus y, then this would be the solution right here. So we define a couple Sims variables. Y at t is going to be the dependent variable. T is going to be the independent variable. DE solution is going to be the solution. Here's our equation. All right. And notice that we have equation is equal. And then the differential equation, diff y at t, this is our y prime, is going to be equal, double equal to right here, the right-hand side, which does not contain a derivative. Right? And then our DE solution is going to be equal to the dsolve, right? And then if we want to solve a second order, what we're going to do is we're just going to make sort of a row vector of conditions, all right? And then we still have the same thing for our differential equation. So if we have y double prime plus 2y prime plus y is equal to 0, notice we use diff y t comma 2. That second parameter represents the second order derivative. And then we have this condition, y prime at 0 is equal to 1, and we also have y at 0 is equal to 2. So we have to put in a row vector of conditions. The DE solution is going to be the same. And then finally, when we go through and we have the solution to a system, we're basically going to do the same thing. As we're going to start to make, we're going to define our two ordinary differential equations. So I just call it ODE1, ODE2. And then we have a row vector. And then we just go through and we define our solutions in terms of t. All right, so that's our independent variable, right? With a system, we have a solution for u, we have a solution of v, and it's in terms of t, so I can plug it back into the differential equation and get a solution that satisfies both differentials simultaneously. Right? All right, so we're just in the next video. We're going to very quickly go ahead and code these just to show you the basic ideas. And I have 3 new problems to where we just go through and use this code just so that way you can get off to a good start with being able to work the analytics side of this.